Hello, Thunderbirds that are taking 7th grade math with me, Miss Matson. I'm here popping on my computer to give you some help so that we can wrap up what we've been working on with percents, decimals, and fractions, which is the end of the ratio unit, which we want to get done before you have a big long break. So here we go. What do we know so far? We've actually done a lot of different things. But pulling them all together to be able to use them whenever you need them is always the hard part. So that's what we're going to review. The first thing you can do is you can take a percent, a percent, and you can make it a fraction or a decimal. So if this is 21%, I can write it over 100 and I have fraction. I can take this decimal point and move it 2 spaces to the left, we say. Get it? So it was on the right side, not on the left side of the 2. And that makes it 0.21. That's the decimal. So that's an easy thing to do. Percents are the easy part. Now, if I have a percent and I want to make it into a decimal, I just do the opposite of what I just did. So here's my decimal, and I'm going to move now the decimal point that direction. So now it's behind the 1, and it's 21%. Just like the last one, but I just kind of flipped my technique. And then again, the fraction stays the same. 21 hundredths is 21 over 100. Or I could look at this percent and say, oh, that's 21 hundredths. Because percents are always over 100. Oh, I'm getting this. Then, if I have a decimal and I want it to be a fraction, this is what I just kind of talked about on the last slide, but I wanted to make it really, really clear. If you look, if my decimal is 0.021, 0.21, the 2 is in the 10th place, which is like 1 out of 10, tenths, or 1 is in the hundredths place, 1 out of 100. 4 is in the thousandths place, which is like 4 out of 1,000. So if I wanted to write it as a out of 100, because that's what percents are, I would have to say, okay, 1's in the hundredths, so it's 21 hundredths, and I write 21 over 100. If I want to make it into thousandths, I would say 214 thousandths, so 214 over 1,000. You say it the same, 214 thousandths, 21 hundredths, but the decimal and the fraction look different. So it's a little confusing, but it's actually kind of cool because it's really the same thing. Mind blown. Now, this is something I do all the time, every day, practically. I'm making percents. I'm figuring out percents. And you always take the part and divide it by the whole. So the part is 4, the whole is 5. So 4 divided by 5 gets me 0.8. And then I move my decimal 2 places to the right. And if you look, I have to put in a 0 here because I had nothing. There's like blank space, and really that means 0. So it's really 80, not 8. That's a mistake kids make. But all I had to do is use a calculator and say 4 divided by 5. I could have done it longhand, but I don't want to. You could just use a calculator. But that's really where that comes from, is just long division, which I know you all love. Okay, we also know how to make a percent of a number. This fraction way, probably not your favorite. Somehow when you see fractions, your brains kind of decide to stop thinking. But 40 out of 100 times 150 over 1 is 6,000 over 100, which I can reduce to 60 over 1, which makes 60. So that helps me figure out the number if I like using fractions. Most of you like percents and decimals and calculators. So if I do the percent to a decimal multiply, which is usually the one I go to, then I can figure out by changing the percent to a decimal and multiplying. 40% is 0.40, 150 stays the same. I multiply and I get 60. Same answer, two ways to do it. But now, what happens when those pesky word problems get in there? And I need to figure out what to do. So what if the numbers are harder to work with? They're not things you can do in your head. And when it comes to stuff like that, our brains look at numbers, and if there's too many digits that are too different from each other, our brain really says to itself, ah, and freezes. Literally, proven true. So our job is to figure out ways to help our brains see the work and find an easier way to do it. And that is using a strategy called a tape diagram. So here is my problem. Lisa bought a pizza at Luigi's for $45.87. Hopefully that's more than one pizza. She left a 20% tip. What's the final cost? So we're going to use this thing called a tape diagram. Our pizza, we know, costs that much. We know a tip is in addition to the pizza. It's a percent of the pizza that you add back together to get the total cost. We also know that the pizza then is the original price, 100%. And the tip is 20 more percent than the 100. And so all we need to do is figure out how much 20% is. So if I want to know 20% of $45.87, I just multiply percent of a number. I change my percent to a decimal, 0.20, and I multiply. And when I do that, my 0.20 times 45.87 gets me 9.174. But that is not dollars. So I then need to round to make it dollars. And the 4 is less than 5, so I can just make it 9.17. So now I know that this tip is worth, the pizza is worth $47.85. The tip's worth $9.17. I put them together, I get the total cost. So when I add them together, I'm going to get my answer of $55.04. But what helped me figure all that out was my tape diagram, which provided an idea of what to do, like a map. But what if it's a different kind of problem, Miss Madsen? These things are crazy, the problems you've been giving us. So what if it's this kind? John bought a new pair of Nikes at 40% off. The original cost was $135. How much did he pay? By the way, I looked up that Nikes to find out what new Nikes cost, and that was on the website. $135 for this like pink pair. So just so you know. So the total cost of Nikes is going to be our bar on our tape diagram. That's 100%, 135. Then we have this part that we're taking away that we call the savings or the discount. And what's left, the other part, is the sale price. Because the sale price plus how much you saved is how much you should have paid. 40% is our savings. And we need to figure out the sale price. So to figure out that 40%, it's the same idea. Multiply 0.40 times 135. I do 0.40 because 40% is the same as 0.40 as a decimal. And when I do that math, I get $54. So the savings is $54. Now I have to figure out the sale price. So if the savings is 54, then I have to subtract that savings from the savings from the total to get the sale price. So 81 plus 54 makes 135, and so I know I'm correct. So here's some templates you might want to screenshot this or keep this in mind when you get your set of problems to work on. Think about, am I finding the sale price? Am I finding the savings? Am I finding the total cost? And the slideshow problems that I have for you with this, you can use the template. I'm going to put some on there. But the top template works for sale prices. It works for original cost problems. It works for percent reduction, percent decrease problems. any time that you're going to take something off a total. And the bottom one works for any time you're going to add something to a total. Tax, commission, percent increase. So those two things, those two little bar graphs right there, those two tape diagrams, if you can figure out where your numbers go from the problem on either one of those, you'll be able to always solve the problem. If, as you're working, you need even more help, if your brain is like mine is in this picture, the SOS button's just going off, I'm available at our Google Meets, 11 to 11:30 every Tuesday, Thursday, or Friday. I try on Mondays, except for I'm at the middle